When you think of cement, you're probably thinking of concrete, the stuff that goes into roads, sidewalks, driveways, foundations of houses and buildings, dams, and so many other things. Concrete is literally the second most consumed substance on the planet after fresh water. But despite how ubiquitous it is, how is it made? What actually goes into this seemingly simple material? How do we turn a runny liquid into a hard solid without even using any type of formwork or molds? And what makes for high quality cement in the first place? That's what we'll explore today. First off, we'll need some cement, which itself is made by heating limestone and other materials like clay and iron ore at around 1450 degrees Celsius, which is about 2600 degrees Fahrenheit. This produces a substance called clinker, which has the chemical composition of 3 calcium silicon dioxide, 1 aluminum oxide, and 4 oxygen ions. It's the main ingredient in Portland cement, which in turn is the main ingredient in concrete. Now we also need some aggregate, which is basically just crushed up rocks and gravel. In order to make the best quality cement possible, you want to reduce these impurities as much as possible. This means starting with high quality limestone. Each quarry will have slightly different impurities, so they all need to be treated differently. For example, if there's too much clay, you can adjust the amount of water and the temperature to reduce its negative effects. Or if there's too much silica, you can add more iron ore to bind up the excess silica and prevent it from reacting with the calcium oxide and lowering the overall strength. It's quite a balancing act. If you heat it too much or too little, it won't react properly and you'll have to throw it all away. In fact, it takes about 3 hours to produce a single batch of cement. But all that work pays off because you end up with something truly unique, a synthetic material with amazing properties. But that's not all. To make high quality cement, you also need high quality clinker. Clinker is the actual material that comes out of the kiln before it's ground up into powder. You can't just turn it into powder and call it cement. There are several tests to make sure that it's good enough to go further. For example, the soundness test measures how resistant the cement is to cracking due to internal pressure. They do this by putting the sample under high pressure and then looking for cracks. If there are any, then the clinker needs to be retried. They also do a fineness test by grinding a small amount of clinker into powder and then passing it through a sieve. The finer the powder and the less that gets caught in the sieve, the better. And finally, they check the strength by crushing a sample between 2 plates and measuring how much force it takes to break it. All of these tests must be passed in order for the clinker to be turned into cement. If it passes, then it's time to grind it up and turn it into powder. The particle size distribution of the powder needs to be within certain limits. If it's too coarse, then the cement won't mix well with the water and aggregates. If it's too fine, then it'll absorb too much water and become unusable. To ensure that the particle size distribution is correct, they use a device called a laser diffraction particle size analyzer. This machine shoots a laser through the cement powder and measures how much light is scattered at different angles. From this data, it can calculate the particle size distribution and tell whether the cement is good to go or needs to be reground. Once the cement is approved, it's time to package it up and ship it off to be made into concrete. But before that, they need to add some gypsum to slow down the setting time of the cement. Without gypsum, the cement would set too quickly and make it difficult to work with. So they add just the right amount to make sure that the cement sets at a reasonable pace. Next up, let's talk about aggregates. You probably already know that the most important property of concrete is its compressive strength. Or in other words, its ability to withstand compression. You can think of it like the weight-bearing capacity of the concrete. The higher the strength, the more weight the concrete can bear. But how does this relate to the ingredients of concrete? Well, it turns out that the compressive strength of concrete is highly dependent on the quality of the aggregates used. This is because the aggregates make up 70% of the volume of concrete and therefore play a major role in its properties. In order to make high quality concrete, you need high quality aggregates. For example, the maximum size of the aggregate needs to be less than 1/3 of the smallest distance between bars in the reinforcing steel. This ensures that the concrete can flow around the steel and fill all the gaps. Otherwise, there could be areas where the concrete isn't properly bonded to the steel, which could lead to cracks or even the steel corroding. To make sure that the aggregates are high quality, they need to be tested for things like their shape, size, strength, and purity. For example, if the aggregates are too angular, then they could scratch up the mixing drum or damage the concrete mixer, which would lower the quality of the concrete. Similarly, if they're too rounded, then they won't pack together tightly and the concrete will be weaker. Also, you don't want aggregates that are too strong because then they won't break up properly. And again, this will lower the quality of the concrete. This is because water that's too dirty or contains impurities can react with the cement and aggregate and make the concrete weaker. Additionally, if there's too much water, the concrete will be runny and won't hold its shape. If there's too little water, the concrete will be stiff and difficult to work with. That's why all the water used in concrete production must be clean and free of any impurities that could affect the quality of the concrete. In conclusion, making high quality cement is a complex process that requires skilled workers, specialized equipment, and rigorous quality control. Every step of the way, from mining the limestone to testing the cement, there are opportunities to improve the quality of the final product. By using high quality ingredients and following strict production guidelines, manufacturers can produce cement that meets the demanding requirements of modern construction projects. Whether it's a towering skyscraper or a simple sidewalk, the quality of the cement used will directly impact the structure's strength, durability, and appearance.